All right, folks, welcome back. I hope you enjoyed your lunch and the famous Menlo Park sunshine out in the Zen Garden there. So we're kicking off this afternoon now. Unfortunately, the slot after lunch is always the one that, people tend to drift off a bit and they're not quite there. So hopefully you've all had plenty of coffee. The good news this time is that the session after lunch today is the one where you're really going to find out about some of the amazing extra features that Hack offers over the top of PHP. And so it's going to be a really, hopefully, excellent session that'll help you investigate some of the new things we've added and give you lots of ideas of how you can use them in your own code base. So without further ado, I'm going to hand over to Drew and leave you in his very capable hands. Take it away.
Thank you. Hi, everyone. My name's Drew Paroski. Eugene Letuchy and I today will be presenting about Hack's language features. So before I begin, just a little about me. I started the HHVM project with two other engineers back in 2010. And in the early days, I worked on a bunch of different parts of the system, including the JIT. And in particular, I designed the bytecode specification, the bytecode, and wrote the spec. More recently, in 2012, I was one of the engineers that started the Hack team. And so the last 2 years or so, I've been working on language features for Hack, in particular the collections framework, which you'll be seeing in a little bit. So getting started. So you've heard about Hack's type checker that alerts you about errors ahead of time. It's great, helps you be more productive, helps you find bugs without having to run your code, or worse, discover them in production when some poor user has hit a page that doesn't load correctly. So just like a traffic signal, it tells you, gives you a red light or a green light about whether you're safe to go. But as you've heard some of the previous speakers today say, not all of PHP's features jive well with static typing, and in particular, there's two PHP arrays and traits that you can make it work, but they're just not a natural fit. Also, Hack is a gradually typed language. You can add type annotations as you want and leave certain parts of your code dynamic. So as such, you're still going to run into type mismatches at runtime. So unlike languages that are fully statically typed and not gradual and require you to type everything, you can still get type mismatches for the parts where they weren't fully type annotated. So given that context, the language features that we've built for Hack are designed to work smoothly with static typing and be safe in this gradually typed world. So before I dig into features, there's one simple but very core feature, which is type annotations and specifically how they behave at runtime. So here I have two examples of type mismatches, one with a parameter, one with a return type. So you'll recognize the parameter type hints if you're familiar with PHP 5. We've added scalar type hints for parameters, which is something PHP 5 doesn't have. So PHP 5 lets you do array and object types. We let you also do int, string, bool, and float. And so like PHP 5 parameter type hints, if you pass a mismatch incorrect type, you'll get it'll blow up at runtime. You'll get a fatal error. It'll tell you, I wanted this type. You were passing this type. And then similarly, when we added return annotations to Hack, we made it have similar enforcement. So it checks the value that's actually being returned, make sure it's the right type. These checks can be optimized away if there's sufficient static typing where it can prove that I know this thing is the type I'm expecting. But in some cases, it has to do the check at runtime. So this kind of helps all the type annotations you're adding to the code actually be grounded in reality. If you didn't have this, you could have types that are all self-consistent with each other, but don't actually match the objects that are flowing around at runtime. So this kind of keeps you anchored, make sure that your type annotations are actually correct. So with that, I'm going to jump into the first feature I'm going to cover, other than type annotations, is Lambda expressions. So this one's a short feature, short and sweet. So if you're familiar with PHP, you'll know that about a couple years ago they added a closure feature. So here I have you showing the syntax of how it's done. Use the function keyword, but you don't put a name afterward. And then you're able to put a body. So this lets you make an anonymous function in line. And you're able to capture variables from the enclosing scope as well. So you'll see the use clause is saying capture local $B from the enclosing scope. Then later, not necessarily in the same function, often not in the same function, you can invoke this callback object thing that got created. Pass it a value, it'll execute the anonymous function and return you the value. So Hack, we added a feature very similar called Lambda expressions, except it's superior in a couple of ways. First, you'll notice that it's just much shorter. If you compare the two, you'll see that Hack Lambda syntax doesn't have kind of the keywords that aren't really that meaningful: function, use, return. Also, you'll notice I didn't have to explicitly list $B as a variable getting captured. Hack Lambda expressions will just automatically detect what local variables you're using from enclosing scopes and import them for you. So there's a good side-by-side comparison of what the two look like. So what are the benefits? I already mentioned they're more concise, and you get the nice automatic capturing. Automatic capturing comes particularly in handy if you're using callback-style APIs a lot, or if you have callbacks that return callbacks. And I mentioned Hack's collection framework earlier, which we'll get to in a second. That has a bunch of callback-based APIs as well. So Lambda expressions make it even easier to use Hack's collections. And finally, Hack's Lambda expressions create the same kind of object at runtime that PHP Closure Expressions do. So you get nice smooth interoperability. You can gradually add Hack Lambdas to your code base as desired. To the consumer of the callback object, it looks the exact same. So consumers aren't affected. They can't tell which syntax you use to create it. So that lets you gradually add them as desired. So here's a few more examples before I move on to collections, just to kind of give you an idea of how this feature works. So earlier I showed a simple example with just one parameter. But if you want multiple parameters, you can do that. You just need to throw parentheses around the parameter list. Also, if you want to do 0 parameters, you can do that, but you need the parens. If you don't have curly braces on the right-hand side of the arrow, it just assumes it's an expression and that's what's getting returned. But there are cases where you need a multi-body statement. So sometimes you need to call a function, store something in a temporary variable, and then be able to use that. So this example, I needed to use y twice in the call to bar. So I use a temporary local variable. So just slapping those curly braces on the right-hand side lets it know this is a block of statements, not an expression. And finally, you have transitive capture. So depending on your programming style, this might arise never or frequently. But basically, if you have a callback that returns a callback, or you have them nested in any way, if the inner Lambda expression uses a variable, the feature is smart enough to make sure it kind of gets imported from multiple enclosing, outward scopes. So even though Z doesn't get referenced by the outer Lambda expression formally, it gets referenced by the inner one. We make sure that that works. So you can see this ends up adding the 3 numbers, 3, 4, and 5, and you get 12. So on to collections. Collections, what is it? It's basically a framework, and it's a set of language features and APIs that serves as a complete alternative to PHP arrays. So here I show, thank you. So here I show kind of what they look like side by side, just to get you real familiar. If you already know PHP arrays, you'll see that the Hack collection syntax is fairly similar. You have your literal syntax. You use the arrow when you want to have maps to separate the keys and values. And that's kind of what it looks like when you want to use a type hint on a function. As I mentioned, they fit well with static typing, so you can see we got the generic type there that tells you the key type and the value type of that map. So Hack offers mutable and immutable collections. For now, I'm just going to talk about mutable. So there's 3 basic ones you need to know about: vector, map, and set. And before I go into more detail, I'm going to do a quick map filter example, just to give you a feel of what this looks like when you're using collections in your code. So here's kind of the canonical way you would write map and filter with PHP arrays and the APIs that PHP offers for arrays. And if you read this, you'll notice it's a little clunky. So it doesn't actually, array map executes first and then array filter, but it's written in outer to inner order. Also, oddly enough, array map and array filter don't take their parameters in the same order. So array map wants its callback as the first parameter, and the container is the second. Array filter is flipped the other way. So that's kind of what this example looks like with PHP arrays. Now I'll show you the comparison of what it looks like with Hack collections. So first of all, you'll notice that it's shorter. And also it has the nice left to right flow as you read it. You're reading it, okay, I have the container, then I do a map with this callback, then I do a filter with this callback, I get my result. So it's nice and clean. And for those of you who are fans of object-oriented or functional programming styles, I think this is a welcome alternative to PHP arrays. Now, in that previous example, I assumed you already had callback objects set up in FN1 and FN2, but let's look at what it looks like when you want to use the callback inline. So this shows PHP arrays mixed with PHP's 5.3's closure syntax, and this is pretty bulky. You're going to have to write this on multiple lines, and Again, the arguments being taken in different order, it being from outer to inner, all the extra keywords like function and use, makes it kind of hard to grok what this is doing. And so I'll show you what the alternative looks like if you use hack collections. So Lambdas really make collections APIs light up. So you can see we have the same arrow map, arrow filter that you saw in the previous example, but then here you have nice, concise Lambda expressions to provide the callbacks to those APIs. And with the automatic capture, you don't need to mention explicitly that you're capturing B from the enclosing scope. Now I'll do a quick demo to show off what map and filter looks like when you have the hack plugin for Vim installed, which you can get from hacklang.org. All right. So I have a little demo here with some fake classes. This isn't the real Facebook codebase, but it's themed as if you have posts and users. And so the idea is this little stub. We haven't implemented it yet, but the gist is it's going to take a vector of posts, and what it needs to do is get the authors of those posts and then only return the authors that are friends with the specified user. So now I'll start writing the implementation and kind of show off what it feels like when you're using hack collections. So first of all, one of the really neat things is that the Vim plugin gives you autocomplete. So with hack and the type annotations, it knows what the type of post is because it was decorated in the signature. And now we can look through, and first what I want is map, because I need to go from posts to author of the post. So I'll do map, and then I can use Lambda syntax. So I'm starting with posts. So I do a Lambda, and then awesomely enough, it knows what the type of P is in the Lambda because of the context it's used in. So again, we can see the methods. We want the author, so we'll take that. Great. Halfway done, but we still need to filter based on whether the author of these posts is friends with the specified user. So then I chain on a call to filter. And now I'm going to do another, and by the way, you could do autocomplete with filter as well. And then I'm going to use one more Lambda to filter out the ones, only the authors that are friends with the specified user. So now I do autocomplete again, and even through this whole flow, it's able to follow the original type of posts and then how it transformed as you did the map, knowing that it's now a vector of users. And then finally, when you do the filter, it knows that the $U in the Lambda is a user, so it's able to show me the APIs that user offers. Didn't want get first name, actually. What I wanted was is friends with, a nice convenient API that will return a Boolean for us. And with that, I have my map and filter done. So now I go to save, and the hack type checker, which is part of the Vim plugin, runs automatically when I save, and it yells at me saying invalid return type. And so I can bounce around, and it says, invalid return type, this you claim you're returning a vector, but you don't have a return statement. So the return is implicitly void. So I can just fix that by now slapping in a return statement. And now I do one more save, and everything should, as you see, no more errors popped up, so now I know I'm good to go. So that's it for the demo, and I'll go back to the slide. All right, so we showed off some of the cool stuff about collections, and some of you may still be asking, why bother? Why not just use PHP arrays? So some of the benefits, hack collection framework defines separate types for vector, map, and set, the different use cases. And so we'll get into kind of why it's clunky to try to have one data structure do everything, and you'll see some of the benefits there. Also, I mentioned earlier, it's designed for object-oriented and functional programming styles. You can still use these things procedurally with brackets and for each loops, but you can also do more OO and FP styles. Also, unlike PHP arrays, collections were designed from the ground up with static typing and generics in mind. They offer cleaner APIs that are a bit more well thought out. And finally, this is an important point, they don't have the backwards compat baggage of PHP arrays. So we're building this new thing. Hack's still kind of a beta at the moment, so we have a little freedom to change it if we run into problems. Whereas PHP arrays have been around for 20 years, or pretty much ever since PHP came into existence in '95. And so at this point, you really can't make any substantial changes to how PHP arrays work. There's just too much code out there that depends on all their little quirks. All right, so a few notes on the design behind hack collections. Parts of the design were inspired by collections frameworks from other imperative languages, C++, Scala, Java. But I'll emphasize that it's not a wholesale clone of any of these. The Hack collections framework was specifically tailored and designed to be the core of the container story for Hack. I mentioned we have separate types, so each separate type of collection is represented using a different generic class. I showed you vector, map, and set. We'll see the immutable ones a little later in the presentation. They're made to be very easy to use, at least as easy to use as PHP arrays. Ideally, we can exceed that ease of use. So I mentioned for each and bracket syntax works the way you'd expect. We have literal syntax, which you may have seen at the beginning of this presentation, that makes them just as easy to construct as arrays. And then we have well-designed APIs. We also offer some collection interfaces to provide added flexibility. Since you don't have the one true data structure of PHP array, it's nice to have interfaces, so you don't necessarily have to be pinned down to a specific collection type, but maybe you just care that when you for each over it, it produces a certain type of value. Finally, while we wanted to improve a lot of the issues with PHP arrays, or kind of overcome those some of those flaws, we did design it with migration in mind. We understand that Hack, one of the main selling points is that you can use it with your existing PHP code base, and so collections being part of Hack, no different. We wanted to make sure that if you have arrays in your existing code base, that it's not too hard to start introducing collections. So I mentioned there's some downsides to the one-size-fits-all approach. PHP arrays try to be a vector and a map at the same time. The shame of this is that typically when you create an array somewhere in your source code, that given array, you pretty much only intend to use it as a vector or only as a map for its entire lifetime. So you're losing kind of type information about the structure of this thing by having to call them both array. And also because of this, you get kind of subpar API design and developer confusion over whether they're dealing with a vector-like array or a map-like array. And so array merge is kind of the poster child of this issue. So I show an example with array merge. One we have, we're doing two arrays on the left with string keys, and then two arrays on the right with integer keys. So array merge tries to tell whether you're passing it a vector-like array or a map-like array and do what you wanted. And it does that by looking at whether it's a string key or an integer key. So fun trivia, if you have string keys, they get preserved and the right-hand side wins if there's conflicts. But if you have integer keys, they get renumbered from 0 to n-1. So works great if the arrays you happen to pass in were vector-like, but what if those integers were meaningful? Maybe they were user IDs or something like that. And now you get a nasty surprise when the result of this now has integers 0 through n-1 instead of meaningful IDs. Another thing, you can emulate sets with PHP arrays, but it's clunky. You're basically doing a map, and then you have false values, and the keys are actually the real interesting values. So here I show one possible scheme where you have string literals A and B as your values, and you put them in the keys so that you can quickly index and check for their existence, as I show with the if is set line below. And then you have to remember when an array is set-like when you pass it to various common APIs. So you can't just pass X to implode naked, because implode is only going to look at the values, which are not interesting. They're Boolean true for all of them. What you really want is implode to look at the meaningful value, which is the key. So you end up having to call array keys on X prior to passing it along to implode to get it to do what you want. And finally, not everyone agrees on the emulation scheme of how do you encode it. So I show one scheme here where I just have true for all the values, but maybe you use something else as the dummy value, or maybe you use the string for both the key and the value. So different programmers can have different schemes, and then when you try to get their code to talk to each other, might not work so smoothly. So one of the other things that Hack Collections kind of solves is jiving well with static typing. So here I show an example of PHP arrays and how they work with Hack static typing. The main point here is that this function says ostensibly takes an array of string, and we're actually passing it an array containing only strings at the call site below the function definition. But then when you get to the first line in bar, it goes to read out at index 2. Index 2 is not present. This array only has one element at index 0. But PHP arrays kind of follow the general PHP philosophy of keep running at all costs, even if it's not probably going to produce bad results. And so what happens is it raises a notice, which you might not even have turned on depending on your PHP config, and then it outputs null into $s. And then who knows how long you end up running with something that isn't a string until finally you try to pass it to foo, which has a string annotation, and it'll blow up at runtime. So the idea is that with collections, we didn't want to do that. We wanted fail fast so that you could diagnose the problem as close to where it's actually happening as possible, rather than having to have it blow up, potentially in a totally different file in a different context. So with this example, kind of it parallels the previous example of PHP arrays, but the key difference is when you go to read a non-existent key, it throws an exception right there. So you'll get a nice stack trace saying, hey, something's goofy is going on here. One more quick example. You're for eaching over an array with a string key, or what looks like a string key, 1, 2, 3, and then we print it out and then pass it to foo, which is expecting a string. But surprise, when you for each and pull it out of the array, it's not a string anymore. PHP did you a favor by changing it into an integer because it looks like an integer-like string. And again, it fits well with kind of the philosophy of, it doesn't matter if the type's exactly what you want. Let's just kind of slosh the values through and get your request to keep running. But then when you actually go, again, try to pass it somewhere that has a type in its string, it's going to blow up at runtime. So collections, we decided not to mimic this feature of PHP arrays. And so if you put in an integer-like string, it's going to stay a string when you iterate and pull it out. Another difference, just I want to cover really quickly between PHP arrays and HACS collections. PHP arrays have value type semantics, and you don't really need to know the nitty-gritty, but the gist is that when you assign a PHP array to a variable or you pass or return it, a logical copy is made. So the engine is free to optimize that, maybe try to defer the copy, but the point is they're distinct, they're separate copies. And so you'll see I'm passing bars $x to f and g. F just takes the parameter normally, and so f actually gets its own copy of the array. So when it makes a mutation, after it returns, bars $x is still the empty array. So you end up having to use PHP references in practice in certain cases so that you can allow the callee to modify the caller's array. And references pose a challenge for static typing. At the moment, HACS type inference just simply ignores the ampersand when it's kind of analyzing types. And so we didn't want the core container story of Hack to be something where you had to use references. So we designed collections to be objects. So if you've used ArrayObject or any of the SPL collection classes, same deal. Basically, if you pass it to a caller, the caller can modify it because objects have reference-like semantics. And then, it arose of, what if the callee wants to say, I'm not going to mutate it? So we have, I mentioned there's interfaces earlier. We have a const map interface, which only exposes the non-mutable parts of maps API. So that's a way you can indicate. And then the type checker will yell at you if you try to call an API that mutates $A inside G. One other interface I'll mention real quick, although I don't have time to go into depth, is the iterable interface. So you saw map and filter. There's lots of other good higher order function goodness, and it pretty much all lives in the iterable interface. And so the idea is that we want to make it so that we have a foundation for building good APIs that can work not just on collections, but also other sequence-like things. So you can think like generators or other such things. So earlier I mentioned there's both mutable and immutable. Thus far we've pretty much only talked about mutable collections, but HACS collection framework also offers immutable flavors. So you have imvector, immap, and imset. And so these are useful when the programmer wants runtime protection against modification. Or if just, you know for a fact you never need to change this thing after you construct it. And the collection APIs make it easy to convert between mutable and immutable collections as well. So you might have say, hey, wait a minute, I saw that const map or const vector interface in a previous slide. How are immutable collections different? The difference is map and immap are concrete classes. One of them allows mutation, one of them doesn't. Const map is an interface, and they both implement it. So if you have a function and you want to be able to take either an immap or a map, you don't care, you don't plan on mutating it, you can use the const map interface. And vector and set have similar interfaces, const vector and const set, respectively. So here's a quick example. There's, like I said, there's a couple different use cases, but I'll just show you one, which is you have a collection that you're holding internally inside an object. Here it's class C. And, maybe you need to mutate it internally, maybe not. But the point is, you need to have an API that exposes the elements of that collection, but you don't want to let callers be able to mutate the collection on you. You want some protection, some compartmentalization against that. So there's two possible schemes you can do. So the first one is maybe you build the thing and then you don't change it very often, or not at all. And so you can just have immap right as your property. So you can see token map is of type immap. And then it becomes really easy when you want to expose it to a caller. You just return it, and you're guaranteed that the caller will not be able to mutate it no matter what. And then let's say you do want to be able to mutate it internally a lot, so you don't want to have to like rebuild a new one every time. But when you expose it to a caller, you want to protect against it. So all of the collections have an immutable method that gives you an immutable snapshot of that collection. And we're doing optimizations so that in the common case, this doesn't incur an O of n cost. So that gives you some nice protection. And the reason const interfaces aren't sufficient for protection is that it's a gradually typed language. So while that example I had before took a parameter const map, nothing stops it from passing it somewhere that's untyped or that has a mixed annotation. And so at that point, someone could then downcast it to its real type and modify it. So that's one of the great things about immutable collections is they prevent the really strong protection against mutation. So I mentioned at the beginning, we considered migration and wanted to make sure that it wasn't too hard to introduce collections into your code base. So we've done a couple of things to just try to make things work as smoothly as possible when you introduce collections into your code base. So one of them is that a lot of your common built-in array functions that you probably use throughout the code base, if collections happen to flow into those as well, they just work the way you'd expect. They work as if you had converted the collection to an array right before passing it in. And then common constructs work the same as they do for PHP arrays. I already mentioned for each and bracket syntax. But another key one is, testing whether it's empty by doing if or Boolean cast or not. And then all the different ways that you can use is set and empty on arrays. We made sure it works with collections as well. You also have list assignment serialization. List goes on, but I didn't have room on the slide. And then two more things worth noting. If you have an array annotation on one of your functions, a collection happens to flow in, we'll gracefully convert that to an array for you, give you a notice, let you know what happened. But at least your program keeps running and is still type safe. And finally, we actually played around with this when we did map and set initially, but we decided we should just retain insertion order the same way PHP arrays do. Because without realizing it, you end up depending on when you put things into an array and then you take them out, whether you know it or not, some of your code probably depends on that insertion order being preserved when you for each over it. So some future directions of stuff we're planning to do with collections specifically. We're building out the iterable interface more and adding more higher order functions, flat map, group by, a bunch of the ones that are present in other languages with rich FP libraries, functional programming libraries. We want to do runtime enforcement of key types and value types. So at the moment, the type checker is the main thing that prevents you from inserting incorrect values into a collection. But if you happen to be an untyped code, nothing at runtime stops you from inserting a string into a vector that's supposed to only contain objects of type foo. We want to add support for using objects as keys for maps. So right now, maps only support int and string keys, very similar to PHP arrays. But there's some use cases with both with maps and a few values for sets, where it comes in handy to be able to use the object as a key or a value in a set. We want to make it so that you can roll your own collection classes and have it work smoothly with all the interfaces, the literal syntax. So that's something that we made sure we left the door open and didn't block off that path, but it's just something we haven't built yet. And then finally, we want to do more performance optimizations. So there's some classic ones that HHVM did for PHP arrays. We've done some of those for collections. We're going to see carry over as many as we can. And then there's some optimizations that are unique to collections. So I mentioned the immutable snapshot one being avoiding O of n copies in the common case, stuff like that. And so with that, I will hand you off to Eugene Letuchy to cover a few more features of the hack language.
All right. Hey folks, I'm Eugene, and I'm going to start off by talking about async and await. So async and await is quite a mouthful. So it's cooperative multitasking within a request. And let me unpack that term for you. So multitasking just means that you might be able to have multiple things going on in your program at the same time. So when you are querying a database to get back some rows, it would be nice if you could do some computation that was not related to waiting for the database to return your results. And async await allows you to do that. The cooperative part means that there is a very explicit point where you jump into this, this context of waiting for asynchronous results to come back. And the within request part means that we're not adding a full multi-threading support to PHP. So requests are still isolated from each other, and the execution of PHP code is still fairly easy to reason about. It's very linear in terms of what is going to run on the CPU. So let's talk a little bit more about what it means to have asynchronous computation. So that just means that execution is suspended, and then it's resumed once the result of the asynchronous computation comes back. And your code runs as if nothing happened in between. The way that that happens is functions declare themselves as being async functions by adding a keyword, async, before the function keyword. And then at call time, you opt in to say, OK, I'm cool waiting as long as this takes before resuming processing the result by using the await keyword. And the compiler does some transformations on the async functions and the await statements that are similar to what are done for generators. So here's an example of some synchronous code. You have a function called complex calculations that does complex calculations and returns back to you a result. So it might query some DBs, query some memcache services, do some math, etc. But at the end, it pumps out a result. And then you have a client of that function, the function f, which takes some arguments, calls into the complex calculations, and then does some stuff with the result. So let's see how that looks as async. Pretty much the exact same code, except for the parts highlighted in red. So you've added the async annotation to say that, OK, I'm comfortable waiting on these complex calculations. And then the return value changes from being a result to being an awaitable result. And I'll get a little bit more into what an awaitable is. And then the function f changes to have the exact same thing. It has an async declaration. And then when it calls into the complex calculations, it in turn says, OK, I'm awaiting the result of these complex calculations. And when those are done, I'll have a result, and I'll continue to do stuff with it. So far, pretty similar. The awaitable thing is something that's worth mentioning. So let's say that you change the code for f to look as like the following. You have the arguments. You make the call to complex calculations without doing an await, and then you define the variable $a. So while that is happening, $a is an awaitable object. So it represents the unstarted state of the computation of the complex calculations that we've done. So we haven't actually executed the work of complex calculations. We've just said, all right, we have a handle, and we have an awaitable, and then at some later point, we will await it. So this is a pretty complex slide, so I'll give you guys a second to read it. So the fun stuff happens when you have multiple awaitables going on at the same time. So you have your CPU, which is doing some stuff, and then you might have multiple things that are waiting for I/O at the same time. And being able to do async await in parallel allows you to do that. So let's say that you are generating a web page, right? You have a function called genResponse. It's an async function, so it's something that can be awaited, and at the end it returns the result, a web page. So it does some stuff, and then it calls await this function gen and gives it a vector listing a bunch of dependencies. So those dependencies are the function f, which we met earlier, and some other functions whose implementations are left to the reader, right? Get stuff from memcache, which presumably gets some stuff from memcache, and call thrift service, which might call a thrift service. And at the point of that await up there, we now have a dependency that says, OK, don't go further into this function until we have fetched all of the results, f, getting the stuff from memcache, and calling the thrift service. And then once the await comes back, we're ready to go. We assign $a, $b, and $c, and then we can continue rendering the web page. So let's jump into what this execution means, because I'm getting some stares of questioning from the audience. So we have some code, gen response, right? We've executed gen response. So far, we're doing completely the same thing as we would be doing with synchronous execution. We've assigned user ID, we've called gen, we've passed it the result of calling a bunch of other functions. What that has constructed is the following dependency graph, right? You have gen, which joins together, waiting on 3 separate pieces of computation. So we have f, which, if you remember from the earlier slides, is a wrapper around the complex calculation. And we have a call to memcache, and we have a call to thrift. So at the point of the await, we have this whole dependency graph ready to go. And all that it's waiting for is to switch from serial execution into this await state. So when the await happens, we say, OK, suspend the execution of this code until we've resolved all of these dependencies, gotten all of the results back that we were waiting for, and are ready to continue. So assuming that happens, so the complex calculation happens, memcache happens, thrift happens, you'll notice that there's no dependencies between them, so we can actually dispatch the I/O in parallel. And we don't have to we don't have to say that, all right, we must have unpacked the result from memcache before we can go into F, or before we can go into thrift. But assuming all of these guys come back, gen is now ready to say, all right, my dependencies are satisfied. I am exiting this awaitable execution. And now we can go back into the function. And we jump into the function at this assignment state, right? So we now have results. That is, we have the results of F, we have the results of memcache, and we have the results of thrift. And we can assign them to A, B, and C, and continue with the execution of the function, which in this case is returning our nice new web page. OK, so you might have the question in your mind, all right, I see how an async function involves another async function. How do you get into this state from the beginning? So the answer is that every awaitable has a method called join, which lets you jump from the non-async context into it. So let's say that this is your endpoint code using the same gen response function. You call it, you have a response awaitable, because remember that gen response was also an awaitable function. And then you join on it, and that's the same as saying await, but from the top-level code context. And join, we think, should be used sparingly, pretty much only in the top-level endpoints. So the current state of async await is still a little bit of a work in progress. So we have the kind of the whole chain of dependencies worked out. We have the top-level entry point. The stuff at the bottom, we're still working on open sourcing and polishing up. So what works today is using async and await for batching and rescheduling. And there's a great coalesced fetching example on docs.hhvm.com. And there's some more async-compatible APIs that we hope to open up soon. And those are the ones that would be async querying of MySQL and some stuff with memcache. So the nice thing about the batching and rescheduling is that it allows you to interact with synchronous APIs today, but in a more efficient way that you're able to batch together the calls to those APIs. So it already provides some value, and it'll provide more in the future. All right. And with that, I'd like to switch gears a little bit to one tiny short piece of goodies that we've discovered. So this goodie is constructor argument promotion. So I don't know if you guys have seen this code, but I've seen a lot of it in the Facebook code base. So we have a class C, and it has n properties. So many properties. And it has a constructor. And the arguments of that constructor are the things that will end up in the properties of the object. So the body of the constructor consists of n statements that assign the properties of the object. And sometimes it might actually include some code that does some interesting validation on it. So we looked at this pattern, and we figured out that, wait a minute, this is going to get even worse if we convert this code naively to hack. Because in hack, you have to annotate the properties, so you'll get even more redundancy. You'll have private A prop1, as well as the constructor declaration that the P1 parameter is still an A, and then you still have to assign it. So what this looks like in hack is the following code. We think this is a lot shorter and cleaner to read. All that changed here is that we inlined the argument, right? So the argument to the constructor is promoted to being a property by supplying the visibility modifier. So private A $prop1 does the exact same thing as the code on the left that declared the property, declared the parameter, and assigned the parameter. And by the time that you jump into the body of the constructor, which you might notice is a lot shorter now, the nth property is already assigned. And you can validate on it and provide whatever things that you want to provide. And there's another goodie, which is the critical and one necessary feature of Hack. If there's one thing for you guys to take away today, it's trailing commas. So PHP has this rather odd inconsistency, where when you're declaring an array, you can simply add a comma at the end of the last line, and it's all well and good, completely optional. Your code keeps running. If you try that stuff with a function call, it fails on you immediately, and there's no real way to recover from that. Similarly, if you have a declaration of the function, sure, same fatal. So we thought that didn't really quite make all that much sense. So in order to produce better blame and smaller diffs, Paul Tarjan added optional support for trailing commas in all of these contexts. So yeah, we're very happy. It's critical syntax. Yeah. And if you guys have seen the intro video, Paul is very excited about trailing commas. Yeah. So next big topic that I want to talk to you about is traits. How many of you guys have used traits in your code? All right, sweet. All right, it seems everyone is awake from lunch, so that's good. So I'll breeze through what traits are. So traits are a way of doing code reuse without having to depend on inheritance. And the model is that you are taking some stuff and you're copy-pasting it into a destination scope. So whatever statements you've made in the trait declaration, when you say use this trait, it tries to copy-paste those statements over. And this is pretty sweet for code reuse because it saves a lot of typing with the fingers, but it's pretty hard on static typing and static analysis in general. And here's the general problem with that. So if you have a trait definition, like the one you have behind me, it's very hard to look at that trait definition and see whether there's an error in it. So here we have a trait myFreight. It has a function callf and a function callg, and you might be surprised to learn that callf calls the f function and callg calls the g function. So when you're looking at this, it's hard to say anything about what this is because you don't know what $this is, and you don't know what the use sites of the traits are. So it's possible that you're looking at a hypothetical class that uses the trait, and it declares the function f, and it declares the function g, and f takes a string parameter. Okay, we're passing it a string parameter. G returns an integer, and we're returning g, and it's supposed to be an integer. Sweet, no runtime error. Okay, but does it mean that just because there's no runtime error here, that my trait is not a ticking time bomb of errors? Well, maybe, right? It depends on all of the cases of how my trait is used in the codebase. And here's one of those cases. Let's say that you have a class hierarchy where you have the class C. It defines a function f. And in this case, f takes an integer as its first parameter, not a string as my trait might be expecting. And you have the interface I, which declares the function g. So if we have a hypothetical class that extends C and implements I, we should expect a runtime error, well, sometime whenever callf and callg are used, because we'll figure out that, oh, those type hints don't match. So when you're looking at this, it's a little bit hard to figure out where is the semantic error here? Like, who screwed up? Right? Is it the code of the my trait by calling the f function and the g function? Is it the code of the f function and the g function being just simply incorrect and having incorrect types? Or is it the use statement that this trait was not actually intended to be used with C and I? Well, so determine this intent, you look at what the code looks like. And this is the code that we saw in the Facebook codebase. Most of the time, we've noticed in the Facebook codebase that people use traits in conjunction with type hierarchies that already exist, and they leave comments that look like that. They say, all right, this trait is really supposed to be used with classes that extend C. And sometimes those comments are in line, so they say, oh, pretty please implement the I interface, or this code will fail, and like I'll be sad and have to fix a bug at 3 in the morning. So that is nice, but for static analysis purposes, you really don't want to be reading comments and trying to make sense of this prose. So we introduced something called trait requirements. And that is just a simple syntax, require extends C, require implements I, that is equivalent to those comments, except that it's actually enforced at the use side of the trait. So now we should be able to tell, okay, we definitely intended my trait to be used with C and I, so there's probably the inconsistency in the way that callF is doing stuff and the way that C and I have been declared, and we should point out that inconsistency. So what's that inconsistency? If you remember the definition of class C and interface I, you can see what that is, right? So we require that this class extends C, which means that we know that $this is in fact going to be a subclass of C. And we're calling F, passing it a string, and class C expects an integer. You know, pretty easy error. Probably there's something wrong in the definition of the function callF. Similarly, with the interface case, we are calling $this, G. So we know because there's a requirement that $this must be an I. And we're trying to get a void function and use it as an integer. That's an error, right? So that's the syntax. The nice thing is that we enforce it at the use site, both in the runtime and in the type checker. And we use the information that these trait requirements give us to impose constraints on the trait definition. Specifically, we know that $this must be a subclass or an implementer of these requirements. And that allows us to check the trait definition independently. So we don't have to look at all of the use sites and see if when you put them together, there might be any errors. And because we make it convenient for the programmer to express the requirements of the trait, we can now be a little bit stricter when we encounter a case when we don't know what $this means. So if we go back to the original definition of my trait with no requirements, we can say, okay, we are dealing with a trait which is going into some arbitrary class, and there's a call to $this F. We don't know enough about $this to say that it has an F function, and even if we did, we don't know what the types are. So we can quickly say, hey, wait a minute, you haven't constrained $this enough to tell us what this code is actually trying to do. And it's an easy fix when you get one of these errors, because you say, all right, I think my trait should be used in the following class hierarchy, one line fix, require extends class. Or my trait can be used anywhere, in which case you have to declare an abstract function, F, with the appropriate signature, in which case we know, all right, cool, this will work. So to sum up, PHP 5 traits use the copy-paste stuff into a scope model, which is pretty hard to type check. Because in order to answer the question, does it work, you have to wait for the use site and see sometimes at runtime later that you got an error. Can you answer the question whether there are type errors in the trait methods? Well, it depends. You have to, again, look at all the use sites. And if you want to try the trait to an existing type hierarchy, you have to read some comments and be really good at parsing them. So the hack traits operate under a slightly different model, and that model is that we mix in encapsulated functionality. So similar to the subclass-superclass relationship, we think that traits provide an internal API to classes that use them, as well as the external API that they inherit and then provide to their clients. And this encapsulated functionality comes because it is independently type checkable. So the ability to do independent type checking is really, really necessary because we're working in a model where you have incremental type checking. So a file might be edited and you need to provide a result really quickly to say whether the code has errors. And you might be in a mixed HH PHP code base where there might be other classes that are PHP that are using this trait. And you still get all of the same code reuse benefits of PHP 5 traits. So traits have their own little goodie, and that is trait interfaces. So we noticed a lot of code that looked like the code on the left. So you have an interface, I do stuff, and the stuff that it does is that it defines a function f. And then you have a trait, stuff trait, that says that it implements I do stuff, and indeed it does, it provides the function f. And then you have the class C that uses the trait. And the effect of this is that C gets the interface. So if you have calling code like this, where you have a function with a type hint, and then you try to pass it a C, that works. Yay. That's pretty much the entirety of the goodie. Next thing I'd like to talk to you guys about is user attributes. So user attributes are a way for us to have annotations that are friendly to tools that don't really have much of a runtime effect, but they allow you to build tools that depend on static analysis. And the syntax looks like the following. You have these weird little double less than, double greater than. And if you're reflecting over this function, you'll be able to figure out that class C is awesome, function F is special, and the parameter A is cool. And what that means is sort of up to the tools that you've built on top of this code. So user attributes allow you to provide these tool-friendly annotations without going to either the extreme of having to change the grammar, update the parser, deal with backwards compatibility, or go to the other extreme where you have code in comments, that comments are actually meaningful and no longer comments. As I mentioned, programmer added user attributes don't have a runtime effect beyond parsing, other than that they're available through reflection. So reflection class, reflection method, and reflection parameter all have these get attribute functions. And if you want to parameterize them, you can provide each attribute with a comma separated list of scalar arguments and then get those back through reflection. So some uses of user attributes that we already know about is HHVM system built-ins, or HNI, which Sarah will talk about later. They use an attribute for indicating that some functionality is implemented with native code. There are unit tests that use user attributes for declaring whether something is mockable or perhaps non-mockable. And we have code generation tools where the user attributes allow for passing extra data to the code generation tool. And we have a constructor-based dependency injection framework at Facebook that uses that. And user attributes are very useful for arbitrary tooling that depends on static analysis. And hey, what do you know? We just built an arbitrary tool that does a lot of static analysis called the type checker. So there's actually a feature of the hack type checker that only uses user attributes and doesn't have any other runtime effect. And that feature is override. So if you're dealing with a code that looks like the code behind me, you have a class parent. It exports a public function saying do stuff. And for the actual doing of the stuff, it delegates to a protected implementation function. Then there's a class child that extends the parent, and it overrides the implementation function to plug into the parent's do stuff. So someone might come upon the code of class parent and realize, wait a minute, I can just inline the body of implementation inside do stuff. They go ahead and do that, check in the diff, go to sleep, and then maybe 2 weeks later you figure out, wait a minute, class child was attempting to plug into the parent, and now its override is no longer being called. So the solution to that is a one-liner, right? You have a little attribute called override that you use to annotate the implementation function. And this attribute is the inverse of abstract, is one way of thinking about it. So with abstract, the parent class says, I expect you, child class, to implement some functionality. With override, the child class says, wait a minute, I have some expectations of my parent too. I better be providing an impl that I'm plugging into, otherwise there's an error. So if you try this in hack and somebody refactors away class parent, it'll catch that and throw an error. So as I mentioned, this is a child class counterpart to the abstract. It prevents the refactoring mistakes like inlining the implementation into the parent class. And it also catches typos, which is nice. So if you are off by one character when overriding method and you put override on it, it'll say, wait a minute, you're off by one character. I can't find that method. So now I want to move on to kind of future directions for things that we want to implement in the hack language and the hack runtime, HHVM. So those include things like generics and type variables. Drew touched on this earlier. Specifically for collections, we want to be able to know a little bit more about the types that go into containers. But in general, if you have your own defined generics, we want to be able to enforce more about the type variables that go into them. we also want to enforce Hack's notions of method compatibility a little bit better. And those are, for example, final in traits. Right now in PHP 5, final applies to the descendants of the class that uses the trait, whereas in Hack, final applies to the trait or the using class itself. And another place where we have some disagreement on method compatibility is whether signatures of subclass methods can deviate from superclass methods by taking a different number of arguments or returning a completely different type. We also want to think a little bit more about the standard library. So we definitely want to provide better typing to kind of catch all the corner cases of the standard library, like functions that return false to indicate errors, or functions that fatal when there's when they're past types that they don't expect. And we perhaps want to think about a better long-term version of the library, which Sarah and Paul will get into later. And we also want to provide some options to turn off the rougher edges of PHP 5. So as I mentioned, if there are division by 0 returning false, for instance, is something that you can turn off, right, if you have access to the runtime. And the way that we want to provide this behavior is, first, it becomes a type checker error, where we say, hey, wait a minute, this shouldn't be happening. Then there's a bunch of cleanup that you do, and then you can turn on some behavior that makes HHVM emit the runtime warning. And then after you're pretty confident that you've beat out all the errors out of the code base, you can make that a runtime error and then never have to worry about that issue again. And last, and certainly not least, is your ideas. So we're very open to engaging for ideas for things that we can add to the runtime and to the Hack language. So with that, I'd like to thank you all for listening. And I'd also love to thank some people that worked on the features that I went through in this talk. Yeah. All right. And yeah.
All right.
And we're open for questions. So any of these features which we talked about before.
We have 5 minutes. So.
Yeah.
All right. Question at the back.
Apologize in advance, but I have 2. For the user attributes, the expression that comes in the middle, is that just exposed as a string, so it could be parsed on its own, or back to EXPR?
So it is parsed. So it's the same sort of parsing that happens for default values in functions. So it's a scalar context. So we have the string name of the attribute, and then we have the list of expressions that you've passed.
I mean, conceivably, you could have like vector literals or a map inside the...
At the moment, you can't do collection literals, but that's something we're going to add. You can do array literals, but yeah, right now it has to be all static-ish stuff. So similar restrictions to default values. Collection literals work in default values right now, but we just haven't added them to user attributes yet.
And the second question was, since methods are strictly typed, any intention to have like method overloading, similar to like C++ or Java? We have the same method name that takes different arguments, whereas in PHP you'd have a sloppy method that maybe, like, if this is not the expected type, you cast it to a string or something like that.
So that's something we've been considering, but at the moment, which is kind of the HHVM runtime in the state it's in, and it being a gradually typed language and so forth, we've kind of been putting off, investigating whether that fits well with the language. One concern is that, when something flows into untyped code, then when you go to pass it to one of these methods that has overloads, you end up just using the runtime type instead of the compile time type, because there is no compile time type in untyped code. So you can kind of emulate it right now by just doing an instance of check in the body, and that's kind of where we're at right now.
Yeah, it's the mixed type hint is sort of a way of doing that. So mixed basically means that if you want to figure out what type it is, you have to have an instance of checks. So works with that.
It's a question about the async and await. Mm-hmm. Do you guys have a way to catch errors in case if anything fails in the process, or would Hack will use the PHP standard error handling?
So we use the standard error handler with warnings, notices, stuff like that. with async and await, kind of the model of handling errors is exceptions, which is kind of the model we've been pushing for in general of make more things exceptions instead of unrecoverable errors, so that you can kind of have boundaries in your code that are able to keep part of it running even if like one component of your page messes up. So basically, exceptions fit really nicely. If in your async function an exception gets thrown, what will happen is the awaitable holds on to the exception for the time being, and then when you actually go to await on the awaitable, at that point the exception propagates out to the function that did the await.
Good question. Wow.
I think we got it.
Mm-hmm.
How do you work with overloading in a strict tackling project?
When you say overloading, what do you mean exactly?
Which way?
Autoloading, yes.
Autoloading, yeah. So, so the question is, how do we make autoloading work for a strict hack? Yeah, so that is actually something that hack actually has some dependencies on autoloading in order for it to work. So in hack, you are dealing with classes that are always defined at the top level and not conditionally. So if you have any autoloading that's happening, we just assume that a class that the hack type checker can see at the top level is a class that will be autoloaded. So when looking at strict hack, if you see that name used, we assume that autoloading will happen and that name will come in. So that's sort of the reason why hack doesn't support conditional class compilations, or fetching half of the code of a class from a database, half of it from memcache, sticking it together and evaluating it, right? Because that's very difficult to statically analyze.
And yeah, it can also work with just regular includes and requires. If you don't use autoload, it just assumes that somehow you've gotten the class loaded at runtime. If it's not, you get a runtime error. We got time for one more question before the next. I don't want to cut in.
Yeah. Yeah.
Yes, Asm89.
Yeah.
I know his GitHub handle.
Yeah. I got one.
Okay,
Right.
Either one. You guys go first.
How's the support with namespaces?
Namespaces work. That's
So the Hack's runtime HHVM has full support for namespaces. Everything works. We're adding the new namespace features that are getting added to 5.6. So we'll have those as well. So you can do use function, use const, all that good stuff. Hack also does recognize namespaces. There's a few bugs in it that are being worked out that we know about, but Hack should be pretty smooth about understanding namespaces within the next month or two.
Yeah, so if there's anything in namespaces that Hack doesn't understand, it's a bug rather than an intended limitation.
Sorry, I meant
that makes sense.
to clarify, I meant the type checker not understanding namespaces. Runtime knows it really well. Yes.
Yep. All right, one last question.
One more.
So, are there any performance benefits of using either mutable or immutable collections?
That is a great question. So yeah, the runtime is going to be able to do a little bit more optimization with immutable because it knows that there's no way that through aliasing elements can be changed. So when it's for eaching, it doesn't have to worry about that. Also, if you have an immutable collection whose contents are all kind of static scalars, it can just do the same thing it does with PHP arrays that contain static scalars. It can just kind of make one of them at the beginning of the HHVM process when that code gets loaded, and then it doesn't have to keep reconstructing it every request. It can just reuse it. And immutable collections, like I said, we're trying to get the performance to be as good as arrays or better. Since we know more about whether you're using it as vector-like or map-like, and we know the element types, we're kind of hoping in the long run that we can have a noticeable performance benefit over PHP arrays.
And even if we don't have a performance benefit now, this telling us the intent of the programmer is to create something that's immutable opens up the possibility of creating better performance in the future. So if we find them being used a lot, we'll optimize the performance more because we can. Yeah.
All right.
All right, I think we're just about on time. So thanks very much, guys. Another round of applause for an awesome session.
Thanks, guys.
And I think we have a very short break now for 10 minutes, so stock up on some caffeine, goodies, little kitchen out the back there, food, snacks, and so forth. We'll be back here in 10 minutes. Thank you.